Good morning, students. I hope you all are doing well. So, in my previous class, I have explained you about chemical changes and chemical reaction and have given you some examples about chemical reactions. In that chemical reaction, we have seen that there are different types of chemical reaction. So, today I am going to give you a detailed description about the types of chemical reactions. As you can see in the diagram, there are four main types of chemical reaction: combination reaction, decomposition reaction, combustion reaction, and then neutralization displacement reaction. This neutralization reaction and displacement reaction are type of single displacement reaction and double displacement reaction. In today's video, we are going to learn in detail about this uh, types of reaction. So the first reaction is direct combination reaction. Direct combination is reaction is the reaction in which two or more substances, either element or compound, combine together to form a single substance and is called as direct combination reaction. And it is represented as follows. The format for the reaction is A plus B gives AB. It means two elements or two compounds, they combine together and form a product, single product. Now combination reactions are divided into three categories. First is whenever there is a combination of two elements to form a new compound. Second is combination of an element and a compound to form a new compound. And third is combination of two compounds to form a new compound. As we know that reactions takes place whenever there is reaction in between any element or in between any compounds. So three possible types of combination reaction are either two elements will combine, two compounds will combine with each other, or one element and one compound will combine with each other. The example for the first type of combination reaction, that is combination of two elements to form a compound, is reaction of chlorine with hydrogen. Whenever a mixture of chlorine and hydrogen explodes to sunlight, they give hydrogen chloride. If they will be reacted in the dark, no reaction occurs. So activation of reaction by light energy is required. Hydrogen and chlorine gas also combine directly in presence of sunlight. A jar of hydrogen is inverted and placed on a jar containing chlorine in the sun, and soon hydrogen chloride is formed. As you can see in the diagram, two jars are there. One jar is inverted on the another one and it is exposed to sunlight, and when this ray two combine with each other in the presence of sunlight, the hydrogen chloride is formed. This is just one example of combination of two elements to form compound. There are some more examples. Whenever hydrogen combines with oxygen to form water, that is also a combination of two elements to form a compound. Here hydrogen is also element and oxygen is also element. Hydrogen is also element and chlorine is also an element. So these are the types of the combination reaction which takes place between two elements. Next is combination of an element and a compound to form a new compound. So the example of this type of chemical reaction is oxidation of sulfur dioxide to form sulfur trioxide. As you can see, sulfur dioxide and sulfur trioxide both are compounds. So whenever sulfur dioxide is mixed with excess air and passed through an electrostatic precipitator which removes dust and impurities, the purified sulfur dioxide combines with oxygen in the presence of catalyst vanadium oxide to form sulfur trioxide, the anhydride of sulfuric acid. So here we can see that sulfur dioxide is a compound and oxygen is an element. So this type of reaction is the example of combination between one element and one compound to form a new compound. Then ferrous chloride also combine with chlorine to give ferric chloride. Phosphorus trichloride combine with chlorine to form phosphorus pentachloride. Next is combination of two compounds to form a new compound. So here the example of this type of reaction is sulfur dioxide. When react with water, it forms sulfuric acid. We have studied it in acid rain also. In the formation of acid rain, this is what happens. The sulfur dioxide reacts with water and it forms sulfuric acid and forms acid rain. So this reaction is in between two compounds. As we can see that sulfur dioxide is also compound and water is also a compound. So after reacting with each other, they are forming a new compound, and that compound is sulfuric acid. So this is the first type of chemical reaction, combination reaction, and it is its type. Now second is decomposition reaction. The reaction in which a compound breaks down to form two or more simpler substances, element or compound, is called decomposition reaction, and it can be represented as A, B gives A plus B. In combination reaction, we have studied that elements or compounds combine together to form a new compound. So here, as the name implies, decomposition. It means the breaking down of a compound into two or more products or into single element, into their constituent element. As you can see in the examples, 2H2O, that is water, liquid. After electrolysis, it get converted into its constituent element and it got decomposed into hydrogen and oxygen. The next is CaCO3. After electrolysis, it calcium carbonate. Next is CaCO3, that is calcium carbonate. It when the water is mixed with it, it also decomposes into calcium oxide and carbon dioxide. So this type of reactions in which the compound broke down to form simpler elements or two or more product, these types of reactions are called decomposition reactions. Now, on the basis of their decomposition, that how they decompose, under what conditions they are decomposed, this type of decomposition reaction are also classified into three types: thermal decomposition reaction, photodecomposition reaction, and electrical decomposition reaction. Now, what are these three kinds of decomposition reaction? Whenever the reaction takes place in which the compound break down on heating it to form two or more simpler substance, that type of decomposition reactions are called thermal decomposition reaction. The decomposition reaction which is caused by heat. So I have given you the example CaCO3. On heating, it break down into calcium oxide and release carbon dioxide gas. So this reaction takes place on heating, so it will be called as thermal decomposition reaction. Now whenever magnesium carbonate is heated at 1000 degrees Celsius, it gives magnesium oxide and carbon dioxide. This is also a kind of thermal decomposition reaction. Now next is electric decomposition reaction. Electric decomposition reaction is the process in which a compound in its aqueous solution or in the molten state is decomposed by the passage of electricity, is called electrolytic decomposition, or simply we can say it electrolysis. So we have read about electrolysis. It is the process of decomposing water into its constituent elements, hydrogen and oxygen, in which the electrodes are used and the electric current is passed through the water, electrolysis of water it is called, and in that process the hydrogen, the water is converted into, is decomposed into hydrogen and oxygen. So here the reaction is taking place by the passing electricity through it. So this kind of reaction is called electric decomposition reaction. Now the third and last type is photochemical decomposition reaction. The reaction in which a compound is decomposed by light is called photochemical reaction. That this kind of reaction is called photochemical decomposition reaction. Whenever hydrogen peroxide undergoes photochemical decomposition in the presence of ultraviolet light to give hydrogen and oxygen, this reaction is called photochemical decomposition reaction. Here some more examples are there. Silver chloride, whenever it is exposed to sunlight, after some time that silver chloride get decomposed into Ag, that is silver in solid form, and Cl2, that is chlorine gas. Same with silver bromide also. It get decomposed into silver and bromide when it is exposed to sunlight. So this is all about three types of decomposition reaction: electric decomposition reaction, thermal decomposition reaction, and photochemical decomposition reaction. Then there come displacement reaction. Displacement reaction is a chemical reaction in which a more reactive element displaces a less reactive element from its compound. Both metal and non-metals take part in this displacement reaction. Example, reaction of iron nails with copper sulfate solution. This example we have studied in our previous video also. Single displacement reaction, whenever an iron nail is dipped into a solution of copper sulfate which is blue in color. So after some time you will see that the copper sulfate solution will turn into green color instead of blue, and the iron nail the sulfate deposit and it form ferrous sulfate. So here you can see that copper is displaced by ferrous. So this reaction is called displacement reaction because here one element displaced the another element. This displacement reaction are based upon the reactive activity series of elements. As you can see here that this is the activity series of element, and this activity series, at the top there is most reactive elements and at the last there is least reactive element. So in this activity series, the elements which comes before the element, as you can see that potassium is the most reactive element and sodium is less reactive than potassium, then calcium is less reactive than potassium and sodium, then magnesium comes after calcium, potassium, sodium, after it aluminium, carbon, zinc, iron. So these elements are arranged on the basis of their reactivity. So whenever there will be reaction in between two elements, one element and one compound, and the one compound which is less reactive will be replaced by the compound which comes before that compound in the activity series, and this kind of reaction is called displacement reaction. As you can see that iron comes before copper in the activity series, so that's why here in this reaction the copper is displaced by iron because iron is more reactive than copper. Now next is double decomposition reaction. In displacement reaction, we can call it as double displacement reaction also. In displacement reaction, we have seen that there is the reaction between one element and one compound. What happens in double displacement reaction or double decomposition reaction? This reaction takes place in between two compound and in the solution, and these two compound mutually exchange the group of atoms and form the new compound. As you can see, it can be represented by AB plus CD. Here these two are the compounds, and after reaction they exchange their group of atoms and displaces each other, and they form new compound like AD and CB. So the reaction in which more active element displaces, a reaction in which two compounds in the solution react to form two other compounds for mutual exchange of atoms or group of atoms is called double decomposition reaction. Now this double decomposition reaction also divided into two forms, that is neutralization reaction and precipitation reaction. Neutralization reaction is the reaction in between an acid and a base to produce salt and water. Salts are ionic compound consisting of an anion forms an acid and a cation forms a base. So here all the reaction will be in between acid and base. Here you can see HCl plus NaOH. Here HCl is in aqueous solution and it is a acid, and NaOH is a base. So it forms NaCl and H2O. So here sodium is more reactive than hydrogen, so it will replace hydrogen and combine with Cl to form NaCl and form water. So here you can see that this is the reaction between acid and base to form salt and water. NaCl is a salt and H2O is water. Same with the next two equations also. H2SO4 is acid. When it reacts with NaOH, it will form Na2SO4 and gives water. And when HCl reacts with CaOH, it will, for OH whole twice, it will form CaCl2 with water. Then precipitation reaction, when two solutions are mixed, an insoluble substance, precipitate, sometimes form. And this kinds of reaction in which precipitate forms, whenever two compounds are reacted, these reactions are called precipitation reaction. A solid forms, in other words, a solid forms and separate from the solution. Example, as you can see in the diagram, whenever yellow aqueous solution of K2CrO4 is added to colorless aqueous solution of BaNO3 whole twice, a yellow solid forms. So this kind of reaction is called precipitation reaction. Now, when we were studying about chemical changes in chemical reaction, in that one point is there that whenever there will be chemical change, there will be energy which evolve or involve. Always there is a huge amount of energy which will be evolved or involved in a chemical change or in a chemical reaction. So from that we can conclude some point that all reaction release or absorb energy. And the common forms of energy which are released or absorbed in the types of energy changes in chemical reaction are heat, light, electricity and sound. And energy is stored in the bonds of compound. That is, whenever the bonds will be broken and new compounds will be formed, they will release energy. Breaking a bond requires energy, and breaking a bonding, and after bonding they release energy. So there are energy changes in chemical reaction. During a chemical reaction, bonds are broken between the reactions and new bonds are formed between the product. So therefore energy is required to break the bonds, and energy is liberated when bonds are formed. And hence chemical reactions are invariably accompanied by energy changes. These energy changes appear in the form of evolution or absorption of heat and light. Now the energy liberated during a chemical reaction appears in the form of heat, light or sound, while the energy that is absorbed may be in the form of thermal, electrical or photolight, as we have read in the decomposition reaction. So the amount of energy absorbed or evolved during a chemical change is always the same for the same quantities of reacting substance. The internal energy of the substance is the sum total of its kinetic energy and potential energy of molecule. As we have studied in the molecular arrangement, that the molecules or atoms of any kind of matter possess two kinds of energy, kinetic energy and potential energy. So the internal energy of any substance, any compound, any element will be the sum total of these two energies, that is kinetic energy and potential energy. Now, when these energy changes were studied, we concluded there are two types of energy changes, that is exothermic energy changes or exothermic reaction, and endothermic energy changes and endothermic reactions. So here it is endothermic and exothermic reaction. Endothermic reaction is the reaction in which the heat energy is absorbed, and exothermic is the reaction in which the heat energy is released. In this reaction, in endothermic reaction, heat energy is supplied to the reactants from the surrounding. It is represented in the form reactants plus energy के product. A chemical reaction which is accompanied by the absorption of heat is called endothermic reaction. In an endothermic system, the enthalpy of the reactant is lesser than the enthalpy of the product, and therefore the change in enthalpy is positive. It is also important to note that the heat content of the system reaction is raised in an endothermic change. Whenever in an endothermic change the reaction takes place, it will absorb heat from the environment, and its heat energy will increase because it is absorbing heat from the environment. So just the opposite of it happens in exothermic reaction. In this reaction, energy is liberated into the surrounding by the reactant, and the heat energy of the product will be increased. In exothermic system, the enthalpy of the reactant is greater than the enthalpy of the product, and therefore the change in enthalpy is negative. Now the examples of endothermic reaction are melting of solid, fusion evaporation, vaporization, dissociation of molecule into atoms, etc. And hydration process, formation of anions, combustion of petrol, catalytic oxidation of ammonia, etc. are the examples of exothermic reactions. Now as you can see in the graph, as I told you, in endothermic reaction, the enthalpy change, that is energy absorption of the product, will be greater and the reaction will be positive. Why? Because here the reaction firstly was at lower temperature, and when it absorbed the heat from surroundings and it react, then it get converted, it absorb more heat and its temperature increased. So the product will be at the more temperature. So here the product energy of the product, energy absorbed by the product will be greater than the energy absorbed by the reactant. And in the exothermic reaction, the reactant release energy, and after releasing energy it will form a product. So here the energy of the energy which is released, here the energy of the product is less than that of the energy of the reactant. But remember that always the total energy of the reaction will be the sum total of kinetic energy and potential energy. So this is all about your chapter 2. So today we have the chapter 2 is over. In next class we will start our chapter 3. Thank you.